Well, welcome back. You were born to be a calculus student here and to work on our area topic for the day. So, like I said, welcome back, and our goal here is to work on area specifically on our graphing calculator. So, if you don't have your calculator in front of me, you need to stop what you're doing, go get it, and like I said, we are focusing strictly on the calculator today. Now, in the past two videos, we talked about how this is probably a non-calculator question, and that's only in recent years. The past 2 years, the AP has switched over this area volume question that was always calculator to non-calculator. But they could switch back at any time, and it certainly could be a multiple choice question. So like I said, grab your calculator. This is all on the calculator today. All right, so let's start with our first functions here. Y equals x plus 1 and y equals x squared plus 1. Now, I'm not going to do a ton of work by hand. I'm not even sketching these out by hand, which you might be thinking is a little silly because they're pretty basic functions, just a linear and a quadratic. But like I said, if they're going to let us use the calculator, we're going to use it to our full advantage. So I need you to type this in y1, and we'll label it on our paper, and type this junk in y2, and let's label that on our paper as well. As soon as you have that, as usual, you should always be hitting zoom 6, and that will get you to your 10 by 10 window. So like I said, pause it, do that real quick, and meet back with me in a minute. Alright, so here's a picture of my calculator screen at home here. And again, our goal is to find the area between the two functions, so I can lightly put it in yellow here. That would be this section. And my first job is going to be to go and get those bounds, and that's going to be where these two functions intersect. Now, since they're letting us use the calculator, they're not going to be nice numbers, and that's the whole point of the calculator. We're going to have these huge, ugly decimals. So, if I want to find where they intersect, again, this should be review. You're doing that second, trace, choose intersect, and I think you just go enter, enter, enter. There should be directions in the top right corner when you do it, and you need to go get this first value here. All right, so everybody, pause me, go get this value on your calculator. All right, so my first value, I got x equals negative 1.5615, blah, 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 blah. Now, I want to be very clear. You cannot round this number. You only round our final answers to 3 decimal places. This is not a final answer. So you have to, and like I said, this is not an option, you have to store this into alpha A. So what you're going to do is you should have this screen here, right here on your, and it should say, you know, your x, there's that intersection once you found it, x equals something, y equals something. And from this point, you're going to go second, quit. Okay, quit is right next to the second button. And on your home screen, you're going to say, take that x value, which is this 1.5615, and store that into alpha A. Okay, the AP is very clear that you are to store every number. Once you have that, you're going to go back to this screen here, and you're going to do the same thing, and you're going to go get this second point up here. Okay, so you're going to do your second, trace, intersect. You probably have to move closer to it, and you're going to go get that point right now. So again, pause me, do the same thing. Okay, this time when I went and got that number, I got x equals 2.5615, blah, blah, blah. And again, I'm going to do the same thing. I'm just going to go second, quit. So I'm on my home screen, and I'm going to take that x value, so hit x, and store into this time alpha B. Okay, so you should have these numbers stored into A and B. And on my paper, I am going to make a quick sketch of this on my paper. I'm going to put A here and B here. All right, lastly, I'm going to draw in my rectangle, my vertical slice here. And I'm going to say, okay, this one's upper is always on the line. This lower is always on the curve. So one integral will do it for me. And to find this area, I'm going to integrate. My lower bound should be A. My upper bound should be B. Now again, you're not typing or writing these numbers down on paper whatsoever. You stored them in, and you need to use that whole stored value. And then my upper was the function x plus 5. Make sure that's in the parentheses minus the quantity x squared plus 1. Close your bracket, dx. Now, once you have that, again, you're going right back to the calculator, and you are literally typing this in exactly how you see it. So you're going to hit, Math 9, your lower bound, you're hitting alpha A. Your upper bound, you're hitting alpha B. Now, instead of retyping this function in, you'll notice I made a note up here that that function is sitting in y1, and this function is in y2. So you are going to hit that integral a to b y1 minus y2 with your dx. Okay? So again, please do not retype this function in. You're very, very likely to make a mistake doing that. This should be in y1, this should be in y2. So that's that vars, y-vars function y1. And when I type mine in, hopefully you're getting the same thing. I get 11.682. And this is the one I'm going to round my final answer to 3 decimal places. All right, so again, take your time. It's a lot of storing, finding intersections. And again, please don't retype these in. They should be in y1 and y2. All right, so here goes question 2. Y equals 5 cosine of 2x and y equals negative 3x plus 3. And they give us this domain 0 to pi. Okay, so again, let's go ahead and get this typed in y1 and y2. And I'm just going to label this for myself. This is in my y1 and this is in my y2. And I like to always label those on my paper so I keep them straight. And I know, who's on top, who's on the bottom, y1 or y2. Second of all, this domain is so important. This again is telling you your window. If you were just to hit zoom 6, you're going to see this sine curve, or cosine curve, excuse me, cycle on forever. Okay, it's just going to keep cycling and cycling, and it would be very intimidating. So make sure you set your window, so you're changing your x, hit the window button, 0 to pi. All right, so I've graphed it on my screen and took a quick picture of it. Now, you'll notice I want this whole area between the two curves, so I'm thinking this section here, this section, and then again this section. So to me, I see 3 separate areas that I'm going to have to integrate. So let's strictly just talk the first one. I'm going to draw in my vertical slice. Okay, so always put your rectangle in. And now basically you need to picture this slice moving left to right, and it can move left until it hits this bound here, and then it can move to the right until they intersect. So I'm going to set up this first integral. Obviously my x value starts at 0, and it's going to stop where they intersect. So again, on your calculator, get that second trace intersection and store that value into alpha a. And at the same time, I'm going to go ahead and draw this vertical slice in. And again, this can move to the left until it hits here, and then to the right till it hits here. Notice, this top piece is always on my upper line. This bottom is always on the curve here. So I need to go get this point of intersection, and I just need to label it something else. I'm going to call it B. Okay, and remember, I am storing these. You cannot round these answers. We only round our final answers. And lastly, I'll have this section here, so I'm going to draw this slice in. Notice this time this is my upper and this is my lower. And that will be the same if it kind of carries on throughout this picture until this B, and then right up to the end of my graph. And I don't need to guess where that is. Remember, we set our window to pi. So I'm looking at 3 separate integrals. My first one, so I'm going to start with this section here. I'm going to say that's the integral from 0 to alpha a. Okay, a nice big bracket. My upper is that curve, which was 5 cosine of 2x. I'm going to put that in parentheses minus my lower, which is the line, negative 3x plus 3. Don't forget to end your bracket, slap a dx on there. And you have to add to that, so make sure you have a plus sign. My second integral is going to be this section here. So that's going to be the integral from alpha a to alpha b. This time my upper is the line, so negative 3x plus 3 minus my lower, which is the 5 cosine of 2x, bracket dx. And add on to that finally, see this section here, which will be the integral from a to, b to pi. And let's see, the upper is that curve again, 5 cosine of 2x minus the lower, negative 3x plus 3 dx. Okay, now again, this is strictly calculator active, so go right to that calculator and carefully type these in. Again, the other thing I like to do for myself is I'm just going to scroll back up here. Recall that I said this function is in my y1, and again, I always write it down to help myself, and my linear is in y2, and I'm going to label that just, for myself. This is my y1, y2, y2, y1, y1, y2, and that just helps me keep things clear, as I'm typing it in. So again, pause it, take your time, try to type each one in. you know, if you've got that old calculator, you might want to store this into something, but I think you can probably just type it in all on one line. Just be, you know, very careful. So I've tried to take a quick picture of my screen. Obviously you can't see the whole thing there, but you can see my 0 to a of y1 minus y2 plus a to b, and again it gets cut off. But here's my final answer, and rounding that to 3 decimal places would make this 11.366, okay, for my final area. Alright, so I've got one more problem for you tonight. This is an old AP question. I believe it's from 2001. So again, fairly old. And here's the question. It was the first question in the exam, and it's calculator active. Let R and S be the regions in the first quadrant shown in the figure above. Let region R be bounded by the x-axis and the graphs of the following here, and S is bounded by the y-axis and the graphs of the following. So they even labeled it for you, which is very generous of them. Now you can clearly see I cut off parts C and D here, but we can do parts A and B. Find the area of region R. Alright, so as I look at region R, something's got to jump out, and I think you're crazy, and in fact it's an absolute later on that you have to draw these rectangles in, especially when we do volume. You've got to stick them in there. And here's what I'm talking about. You always have to ask yourself, and we stress this now for a couple days, is this function, is this top of the rectangle always on the same curve, or does it change? And is this bottom always on the same curve, or does it change? And I think it's a yes to one and no to the other. This bottom looks like it's always going to sit on the x-axis as you move this rectangle left and right. But this top is currently on the tangent graph, but when I get to this point where they intersect, it's now going to switch, and you'll notice that the top is now on the 2 minus x cubed graph. So what that tells me is you have to set 2 integrals up. Okay, and this is all or nothing. If you miss that, we're in a lot of trouble. So take the time to quickly look for it. Okay, now, I obviously don't know what that intersection point is that I'm going to need, so I'm going to need to put this in my calculator. So you should be graphing y equals tan x and y equals 2 minus x cubed on your screen right now. So go ahead and do so. So once I get them in there, of course I'm going to start with a zoom 6, and then I'm going to come back and read this again. They told me that this graph is in the first quadrant. Okay, so that's their way of telling you a window. If you're in the first quadrant only, if you're just sitting in here, that's telling me you have an x min of 0 and a y min of 0 if you're sitting in the first quadrant. So I'm going to hit my window, and I'm going to change those two things right away, and you can see below here that's what that graph looked like when I changed my x and y min. Now, in order for me to get the picture that I see, I don't need all this extra junk right here. So I'm going to change my window again. And I can kind of see that this, stops before 2, where it hits here. So I'm going to basically, to eliminate this, I'm going to put my x max at 2. And I'm going to say this is a bunch of wasted space as well. So maybe I'll put my x max or my y max at 5 or something. And again, you play with it on your own, but use some common sense. So there's my window, and again, we don't have to have the exact same window, we just have to be able to see the function on each of our own screens. So, to find the area of region R, like we said, we need to get where these two functions intersect, and I'm going to store that into alpha A, so you should be getting that on your calculator. And then I need to find where this function stops here, and I'm going to store that into alpha B. So pause it, go ahead and get those on your own. And hopefully yours match up with mine. I had a 0.902, blah, 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 1.25, etc. All right, so to write that equation, let me just scroll down a little here. I'm first going to describe this, I'm going to go over in red, that red line. So I would say that area of region R is the integral from 0 to alpha A where they intersect. And my upper is on that tangent curve, minus my lower, which is just on the line y equals 0. Now, of course, technically you don't need to say 0 when it's the last term, but I'm going to stick it in there anyway. And I have to add on to that to get this whole area. If I look at that blue one, my upper is on the cubic and my lower is on 0. So I'm going to add on, and that's going to be the integral from A to B. Minus x cubed minus 0 again, which of course because it's on the end I don't need. And then I'm just going to throw those in the calculator and add them together. and I get approximately 2.345. Last but not least, they want me to find the area of region S, and I'm going to draw that rectangle in with an orange slice. And again, ask myself that same question. Is this upper always on the cubic? And I think if I look down, it is. And is this lower always going to be on tangent? And I would say it definitely is. And all I have to do is get my bounds. So I would say this area starts at 0, and it's going to go to where they intersect at A. So for part B here, for region S, I'm going to say that's the integral from 0 to alpha A. See, my upper was on the cubic, so 2 minus x cubed, minus the lower, which was on tangent of x, dx. Now again, in my calculator, I had this typed in y2 and this typed in y1. And I always put that in there for myself so I can type it in quick and easy without having to go back and check so many times. And I get a nice area of 1.161. So, hopefully we did okay, and feel free to come with questions tomorrow, but hopefully, you sat down with your calculator and, practice this on your own. Have a great night.